Hey everybody, in this video we'll be covering 13 through 24 from the June 2019 Geometry Regents. 13. In the diagram below of circle O, chords JT and ER intersect at M. If EM is equal to 8 and RM is equal to 15, the lengths of JM and TM could be. When you have two intersecting chords, the rule is that the product of the two parts of one chord, so like 15 times 8 in this case, is equal to the product of the two parts of the other chord. So 15 times 8 gives us 120. We want to see which answer choice also has a product of 120. So 12 times 9.5, we'll try choice 1. That one's no good. Choice 2, 14 times 8.5, no good. Choice 3, 16 times 7.5, that one works. We get 120, and then our answer is 3. 14. Triangles Joe and Sam are drawn such that E is congruent to M and EJ is congruent to MS. Which mapping would not always lead to triangle Joe congruent to triangle Sam? All right, let's draw a picture so we can see what this looks like. When you label your picture, just make sure that the letters are corresponding. Doesn't really matter so much what your triangles look like. But JOE, think about how you labels it, and SAM, label it in the same manner. So we know E and M are congruent, and EJ and MS are congruent, and we're looking for the triangles to be congruent. All right, number 1, if J maps onto S, that would make these two angles congruent, and in that case, it looks like I would have angle side angle, so that would work. Okay. For the next one, I'm just going to erase those markings as I go through each choice. Choice 2, O maps onto A. Let's say I have those markings. That looks like angle, angle, side. That's a valid method, so choice 2 looks okay to me. Choice 3, EO maps onto MA. That looks like side, angle, side, so that one works. That's a method of proving triangles are congruent. And let's just see choice 4. It says JO maps onto SA. This is giving us side, side, angle. That is not a method for proving triangles are congruent. So that's why our answer is choice 4. 15, in the triangle shown below, ACB is a right angle. E is on AC. ED is drawn perpendicular to hypotenuse AB. I'm going to go ahead and read the problem and label all of the pieces that it tells me. And we're looking for AE. But the reason that this is going to look so confusing is because when we have similar triangles, which is what we have here, the triangles are similar by angle, angle, and I'll show you why, because they both have a right angle. That's the first angle. And both triangles have angle A as one of their angles, so A is congruent to itself by the reflexive property. The problem with this question is that the triangles are not facing the same way. So what I'm going to do is I'm going to redraw. So there's triangle ABC. And I'm going to redraw the small one, ADE. And I'll make that look a little bit better over here. I'm going to redraw them so they are facing the same way. So we know that the two right angles are congruent. We know angle A is congruent to itself, so the triangles are similar. Now let's put that information back in. So AB is 9, BC is 6, DE is 4. What is the length of AE? And now that our triangles are separated, you can see we can pretty quickly write a proportion using the corresponding sides. We're going to cross multiply. I get 6x is equal to 36. And then x is 6 in this case. 16, which equation represents a line parallel to the line whose equation is negative 2x plus 3y equals negative 4 and passes through 1, 3. Okay, so first we have to know that parallel lines have the same slope. So the first thing I want to do is let's figure out what the slope of our given line is. In order to do that, we need to get y by itself. So I first added the 2x to the other side, and now I'm dividing everything by 3. So the slope of this line is 2 over 3. I want my answer choice to have a slope of 2 over 3, so that means I could cross out these two choices. And now using point slope form, let's plug that point in. So point slope form is y minus y1 equals m x minus x1. And when I take that coordinate using x1 and y1 and start plugging in, I'm going to get choice 2. 17. In rhombus TIGE, the diagonals intersect at R. The perimeter is 68. Okay, well, if the perimeter is 68 and all sides are equal, that tells me that every side is 17. And TG is 16. I'm going to split that in half because the diagonals of a rhombus bisect each other. We want to find the length of IE. Let's pull out one of these right triangles in here. You could use Pythagorean theorem or know that this is a Pythagorean triple. 8, 15, 17 is a triple. So that's 15. Since the diagonals bisect each other, RI is 15 as well. And so total, we're looking for IE, add 15 and 15, and you get 30. 18, encircle O. So let's definitely draw this. Any circle one, any picture, any problem without a picture definitely helps to draw. You have two secants drawn to external point P. Secant cuts through the circle like this. And the external point is P, so it's A, B, P, and then C, D, P. If measure of arc AC is 72, BD is 34, what is the measure of P? The rule for this is to subtract the arcs and then divide by 2. So when I subtract the arcs, I get 38. Divide that by 2, I get 19, choice 1. 19, this is a really common Regents question. They just change the numbers every year. What are the coordinates of point C on directed line segment from -8, 4 to 10, -2? That partitions the segment such that they give us a 2-to-1 ratio. So what I would do when I see this question is, if you are not given graph paper next to it, which we're not here, I would go right to your graph paper in the back of your Regents book. You're gonna have to scroll a little, or flip the pages a little. I'm going to scroll on my iPad here. And the Regents scrap graph paper does not have axes, so just draw some in. Use nice straight lines to do this. And I'll adjust that a little. Okay, so our two coordinates that we were looking for were -8, 4. So I'm going to take a second to plot that. And 10, -2. And I'm going to make a nice straight line. You would use a straight edge on your paper. I'm going to make a nice straight line to connect those points. All right, so what I want to do is I want to split this line segment into 3 congruent parts. The reason it's going to be 3 congruent parts is because it asks for a 2-to-1 ratio, so that's a total of 3 parts. You might be able to do this by a little bit of like eyeballing it, but I want to kind of see if I can find the points that split this into 3 equal little line segments. Once you have them, you're looking for the one that splits it so that there's 2 sections to the left, 1 to the right. So that gives us this point here. That looks like the coordinates 4, 0. So I'm going to go back to my question here, question 19. And I see that 4, 0 is in fact an answer choice, so choice 4. All right, 20, the equation of a circle is given to us, not in center radius form. And this is another question the Regents likes to do a lot. You have to complete the square. So what I'm going to do is after the 2x terms, I'm going to leave a little space. Do the same after the 2y terms. And we always have to keep equations balanced, right? So if I added 2 little blank spaces on the left, I have to add 2 to the right. All right, now I'm going to figure out what to fill in those blanks with, and I'm going to look at this coefficient here that I highlighted to help me. I'm going to divide it by 2 and square it. So if I take 8, divide by 2, I get 4. Square it, I get 16. Let's do it with the -12. Cut it in half, or divide it by 2. I get -6. square that, I get positive 36. You'll get a positive every time you do these questions, by the way, because you're always squaring. And I'm going to add those numbers over to the other side. Now let's look at this as if they're two different trinomials. Factor them, x plus 4 times x plus 4, plus y minus 6 times y minus 6. And over on the right-hand side here, we're just going to add 144 plus 16, so that's going to give us 160, plus 36 gives us 196. Well, x plus 4 is being multiplied by itself. That's the same thing as squaring it, so that will help me rewrite this in center radius form. And then to get to the center, we take the opposites of these numbers, so that would give us negative 4, 6. And the radius would be the square root of 196, which is 14. So negative 4, 6 is the center. The radius is 14, choice 4. 21, in parallelogram PQRS, QP is extended to T, ST is drawn. If ST and SP are congruent to one another, that means you're going to have an isosceles triangle that makes these two angles congruent. R is 130. What is the measure of angle PST? All right, well, if that's 130, I know that angle QPS is 130 also because opposite angles in a parallelogram are congruent. I know that over here, these angles are supplementary, so that makes this 50. And we had an isosceles triangle here, that's 50 then too. And then if we take a look, we have a triangle here. Every triangle adds up to 180. So subtract out the two 50s, and that missing angle is 80. You actually could probably eliminate at least choice 1 from this question, by the way. It doesn't look like it's an obtuse angle. And I know that the Regents might tell you it's not drawn to scale, but usually that is at least correct. If it looks acute, it is acute. 22, a 12-foot ladder leans against a building. It reaches a window 10 feet above the ground. I know that this is going to be a question where I have to use SOHCAHTOA. So the ladder is the hypotenuse that's leaning against the building, reaches a window 10 feet above the ground. What is the measure of the angle the ladder forms with the ground? So here's my picture. Now I'm going to label this as the opposite side, the adjacent side, the hypotenuse. Since there's something written on the opposite and hypotenuse sides, I'm going to use sine. So sine of x is equal to 10 over 12. Since we're looking for an angle here, we're going to do inverse sine in our calculator. So second button, then sine. Type in your fraction. And I get 56.44, and that's choice 4. In the diagram below, we are given equilateral triangle ABC. E and F are midpoints of AC and BC. Okay, so EF is 2x plus 8. AB is 7x minus 2. What is the perimeter of trapezoid ABFE? So EF is what's called a midsegment. A midsegment is simply a line segment that connects two midpoints. And when you have a midsegment of a triangle, it's always going to be half the length of the side it's parallel to. So basically, if I double 2x plus 8, it has to be equal to 7x minus 2. This will allow me to at least have an equation that I can solve for x. Okay, I'm going to get the x's on the same side, get the numbers on the other side, and x is 6. All right, now let's fill in what we know here. So EF in this case is 2 times 6, so 12, plus 8, so this is 20. Down here, 7 times 6 is 42, minus 2 is 40. We're looking for the perimeter of ABFE. So I have basically the top and bottom. If it helps, you could just draw it separate over here, even if it's a little sloppy here. That's 20, that's 40. I need the lengths of the other two sides. That's where this key piece of information comes in. The original triangle is equilateral. So if the base AB is 40, this is 40, this is 40, and we know we have midpoints, and that's why each of these sides becomes 20. So if I add up 20 plus 20 plus 20 plus 40, I'm going to get choice 3, 100. All right, our last question, number 24. Which information is not sufficient to prove that a parallelogram is a square? So we're looking for which one of these is not true or not enough to show that it's going to be a square. All right, choice 1. Diagonals are congruent and perpendicular. That is definitely true in a square, so I'm going to cross that off. Choice 2, diagonals are congruent and one pair of adjacent sides are congruent. That means it must be a square. Okay, if adjacent sides are congruent, that means two sides that are next to each other. That's true for a square. All right, choice 2 says that, choice 3, the diagonals are perpendicular and one pair of adjacent sides are congruent. In this case, so I have diagonals are perpendicular, meaning they form right angles, and one pair of adjacent sides are congruent. This could be a rhombus. So that one I'm a little unsure of yet. So let's look at 4. Diagonals are perpendicular and one pair of adjacent sides are perpendicular. Now I know the adjacent sides form 90-degree angles and the diagonals form 90-degree angles. That must be a square. So this answer must be choice 3. Okay, you can head to the next video in this playlist to see the answers to the part 2 questions.